Hello geometry students, I hope yesterday's lesson went well. It is quite challenging to draw out the similar triangles and label the parts accordingly. There are some shortcuts, and so that's what we're going to look at today. However, if yesterday's lesson worked well for you, you can still use that method. So we're going to do similar right triangles part 2 today, or similar right triangle shortcuts. Now the shortcuts would require remembering some patterns, but you wouldn't have to draw out the triangles every time. So if you can recognize these patterns and when they occur within the shapes, it might make your solving easier. And so that's what we're going to practice today. But like I said, you don't have to use them, and if you like your method from yesterday and find the shortcuts confusing, that's perfectly fine. You don't have to use them. So let's take a look at this sample here. If we have a right triangle, and I'm going to make my right triangle with the right angle at the top today. Okay, it's very similar though to what we did yesterday. I just want to be able to talk about the different parts. On a right triangle, please note that this side here is called a leg, and so is the other side that meets at the right angle. So those are legs, with a short leg here, the long leg here. The legs could be the same if the triangle were isosceles, but more often than not we have a short leg and a long leg. Then this side here, across from the right angle, is always called the hypotenuse. And just like yesterday, we're going to label this triangle with the right angle being C. So we'll make this one on the left A and the one on the right B. So we have our right triangle ABC, with AB being the hypotenuse. Then what we can do is we can split this down with the altitude. Altitude is another word for height. It's the height of this triangle, and realize this would be then the base. We could have also looked at this as the base and height. As long as base and height are perpendicular, our measurements still find the area. But that's something we'll work on later on in the year, is working with the area of the triangles. So right now the key thing is just to know the vocabulary. This is the altitude. And there's 3 patterns that can occur. We're going to investigate the first one. The first one is regarding the altitude. So I'm going to sketch out another triangle here. With our right angle and an altitude drawn to the hypotenuse. We're going to call the altitude, why don't we call it A for altitude? Why not? And we'll call this piece B and this piece C. Now please realize that in this small triangle, the short leg is B, the long leg is A. In this triangle, the short leg is A, the long leg is C, and so they match up. So if I go short over long, short over long. And so B over A is equivalent to A over C. Or the pattern, in other words, is part 1 of the hypotenuse over the altitude is equal to the altitude over part 2 of the hypotenuse. And that would save me all that time of drawing it out. Let's do a sample using this one. If I have a right triangle, and this time I'm going to orientate it a little different, but I want you to realize the pattern still works. No matter how the triangle is turned, you could turn your paper if you really wanted. And so we'll get that right angle drawn and that altitude drawn in. And let's say we want to know the height of a triangle. So we're trying to find the altitude. If the altitude splits the hypotenuse into lengths of, why not, 4 and 9 to make our math easy. Okay, so one part of the hypotenuse over the altitude, we don't know, is the altitude over the other part of the hypotenuse. Well, then I have 4 times 9, 36. A times A squared. To get a by itself, we square root, so we have a equals 6. So we just found that altitude is 6. Same work as yesterday, short over long leg, short leg over long leg. You could have drawn these out as the separate triangles to see how they match up, but recognizing the pattern might save you a little time. There's one other pattern, well technically we call it two because you can do it with both legs of the original triangle here. We could use both legs, but really it's essentially the same pattern. So let's take a look at that one. Once again, I'm going to start here. Right triangle, hypotenuse is the base for right now, with an altitude drawn in. What we can do with this, once again, I'm going to label the same pieces, A, B, C, but now we're going to call these D and E. Here, B is the short leg of the small triangle, where D is its hypotenuse. But D is the short leg of the large triangle, and then this whole thing B plus C. And so that's where our other piece comes in. We can do short leg over hypotenuse is hypotenuse over all, or short leg over hypotenuse of the small is the short leg over hypotenuse of all. And so we could say part of the hypotenuse over the corresponding leg, so the leg that it touches, is equal to the corresponding leg over all of the hypotenuse of the large triangle. So if we could recognize that pattern, this piece over this piece over all, and work on building that into our memory, it might make it easier than drawing out all of our separate triangles, trying to identify the different pieces and set up our proportion to solve. We could also do that with this one, right? Part of the hypotenuse, C, its corresponding leg is E, the long leg this time, over all, B plus C. So let's take a look at this one in practice. So let's do an example here. Once again, I'm going to change up the orientation to be more like yesterday. All right. And this time we need some numbers. So let's say that I don't know these two pieces. I want to know how this altitude splits this triangle. And let's use some numbers here of 5 and 13. And 13 is going to be this whole thing. Now, we might not have such nice numbers to work with, but that's okay. Alright, so how we would set it up, if I want to figure out A here, and realize I'm calling this A now and not the altitude, or rather, let's change that. Let's make that an X so there's no confusion. Alright, so we know X is the part over the side is 5 equals the corresponding leg 5 over the whole hypotenuse. Now I get 13x equals 25. Not such a nice answer when I divide it out. I get a denominator of 13. But as a mixed number, I get 1 and 12/13. Let's say we wanted to figure out y. Well, I don't know this side. I could figure it out, and we might just do that here in a moment. But what we can do is we can say, well, if this whole thing is 13 and this piece is 1 and 12/13, segment addition postulate tells me that subtract this piece off and I get this piece. And so we could do that y equals the 13 minus the 1 and 12/13. And therefore giving us y equals, let's see, 11 and 1/13. Say I want to find this side here. We'll learn a much easier way later on, working with Pythagorean's theorem, but we could still use these proportions. I now know y as 11 and 1/13. So 11 and 1/13 over z equals, don't mind that mark there, z over the whole hypotenuse of 13. Now when I cross multiply this time, let's see, 13ths help me out there. I'm going to have 144, doing some quick math, equals z squared, square root, and I get that z is a nice 12. So recapping today, we have two shortcuts. We can look at part of the hypotenuse over the altitude, altitude over the other part of the hypotenuse. Or we could look at part of the hypotenuse over its corresponding leg, that corresponding leg over the whole hypotenuse. Recognizing these patterns might save you some time in setup, but are not essential. I encourage you to try them on the worksheet today. However, if you refer back to yesterday's work, that is perfectly fine. We'll see you tomorrow.